solving a system of equations using elimination, substitution, and graphing. So we're going to solve this system of linear equations, and we're going to use all three methods just so you can see a little bit how they're related, and we're going to use them as our checks for each other. So I'm going to start with my favorite method of solving a system, and that's elimination. Maybe yours is a different method, but my favorite is elimination. So when I look at these two equations, I want to eliminate one of the variables by adding them together. But right now when I add them together, it won't eliminate any variable. Y plus y is 2y, negative 2x plus negative 3x is negative 5x. So I'm going to have to do some manipulation with one of those equations. I'm going to choose to manipulate that bottom equation. I'm going to multiply it by a negative 1. I could have done the same thing with the top, but I chose the bottom one. It would work out the same either way. I'm going to rewrite my first equation. Y minus 2x equals 1. My second equation, I'm going to write it after I've manipulated it, which means I've changed the sign of everything in here. I've multiplied it by a negative 1. So that gives me a negative y plus a 3x, negative 3x times a negative 1 gives me a positive 3x, equals 0. When I multiply this 0 by a negative 1, it is still 0. Now I can add them in order to eliminate my y variable. When I add them together, I have y plus a negative y, that gives me a 0. Negative 2x plus a 3x is going to give me just a 1x, a positive 1x, so just x. 1 plus a 0 gives me a 1. So I know my x coordinate is going to be a 1. Now in order to find my y coordinate, I could go back up here and I could eliminate my x's to find my y coordinate, or I could just use substitution, and I prefer to do that. So I'm going to use one of these equations. It doesn't matter which one, remember, because this coordinate point is where they intersect, so it makes both of them true. And I'm going to choose the first equation. Y minus 2 times x, which in this case I'm trying to solve for y, and so I'm going to let my x equal 1, equals 1. So y minus 2 times 1, which is just y minus 2, equals 1. Adding a 2 to both sides, I have y equals 3. So my y coordinate is 3. This is where those two lines intersect. This is the solution to both of those equations. Now let's try substitution. So I'm going to put the coordinate point up at the top. That's going to be our check. I didn't check with my elimination. I didn't plug it into that second equation because I'm going to check it by doing it a different way. In fact, two different ways. So I have the 1 comma 3 up here, and I'm just going to use it to check my answer. When I have substitution, I'm going to substitute instead of this y, whatever y equals up here. Either way, or I could substitute for this y, whatever y equals. But notice I don't have these equations in terms of a y equals. I have a negative 2x over here and a 3x right here. I don't know what just y equals. So I'm going to manipulate one of these equations. I'm choosing the second one to manipulate. You could manipulate the first one if you wanted to figure out what y equals, but I'm choosing the second equation, and I'm going to solve for y to figure out what y equals. I'm going to add 3x to both sides, and I have y is equal to 3x. Now that I have this, I can take what y is equal to, and I can substitute it into my other equation for y. So instead of y minus 2x equals 1, I'm going to take this y I have from my second equation, and I'm going to take the 3x that it's equal to, and I'm going to substitute it in for my first equation. So instead of a y right there, I'm going to have a 3x. So I have a 3x minus 2x equals 1, minus 2x equals 1. I'm going to combine like terms. The 3x minus the 2x is going to give me just a positive x, and that's equal to 1. Double check over here, that's what I got with my elimination, and now I'm going to go ahead and substitute that x equals 1 into my equation, and I could use this equation, or this equation, because remember this equation is equivalent to this equation, and so I'm going to go ahead and use this equation. Any one of those would give you the y coordinate of this, because it's all that point where they intersect. So I have a y equals 3x. Instead of the x, I'm going to put my 1 that I solved for right there to figure out what my y coordinate is. Y equals 3 times 1, y equals 3, and that's exactly what I got when I did my elimination problem. Now let's try graphing. Graphing is actually my least favorite method, mostly because I don't really like to draw the coordinate grid, and because it's not as precise if you're drawing it. It's much more precise if you use a calculator. But we're going to be graphing now. So I have my equation y minus 2x equals 1, and my equation y minus 3x is equal to 0. I'm going to use 2 coordinate points in order to graph my line. So I'm going to choose a value for x. I like to choose 0. So if I choose a 0 for x, I have a y minus 0 equals 1. And so y is equal to 1. So my first coordinate point is 0, comma 1 for this equation right here. And I can go ahead and graph that, 0 on the x-axis, up 1 on the y-axis. And then I'm going to choose a 2 for my x right here. So I have y minus 2 times 2, which is going to give me a 4. So y minus 4 equals 1. Add a 4 to both sides, and I have y is equal to 5. And I can go ahead and graph that. I'll go over 2 and then up 5, and I can graph that coordinate point, use a straight edge to draw my line. I'm going to do the same thing with my other equation. I have y minus 3x equals 0. I'm going to choose 0 for x. When I choose 0 for x, I put a 0 in there. Y minus 0 equals 0. Y is equal to 0. And I can graph that. That's right at the origin. So I have 0, comma 0. And then I'm going to choose a 2 for x. And I have y minus 3 times 2. Minus 3 times 2 is 6. So I have y minus 6 equals 0. And then I'm going to add 6 to both sides, and I have y is equal to 6. And I can go ahead and plot that point, go over 2 on the x, up 6 on the y, and plot that point, use a straight edge, and I can see it's about here. So that purple dot right here, and this just serves as a double check here. So at 1 and up 3, and that's about what I have there. Now, because you're graphing, and especially if you're graphing without graph paper, it's kind of hard to see. It might be a little fraction there, but because I've done it 2 other ways, this serves as a great check. And the solution to my 2 equations where they intersect is 1, comma 3, the coordinate points where x is equal to 1 and y is equal to 3.